Hello, my name is David Alfonso. I'm part of Team 8 and today we're presenting our project, the UV Alarm. In this presentation, we will be going over the project description, marketability of the product, problem statement and objectives, intended uses and users, background on other relevant projects, intellectual property, ethical considerations, and the final concept. The UV Alarm is a wearable piece of tech that will track the user's UV radiation exposure and provides alerts to protect against skin damage. We intend the product to be water resistant. It needs to accurately measure the UV radiation. It needs to provide audio and visual cues to remind the users to stay safe. It needs to be fully standalone and also be able to connect to a smart device. And it needs to cost less than $100. On average, 2 people in the US die of skin cancer every hour. And the leading cause of this is due to the sun's UV radiation. Most people go outdoors and apply sunscreen once at the beginning or not at all. With the UV alarm, these harmful rays will be monitored in order to keep you safe. Sunburn, vitamin D deficiency, and skin cancer will be a thing of the past. We need to raise awareness in our community about the dangers of unregulated UV exposure. More people in the US are diagnosed with skin cancer than all other cancers combined. The main cause due to UV ray exposure from the sun. The UV alarm will monitor the amount of UV the user is exposed to and provide safety alerts to prevent skin damage. We need our product to be effective at accurately measuring this UV rays. It needs to be able to warn the user and remind the user to stay safe outside, and it needs to be able to do this alone with no smart device near it. This device also needs to be user-friendly. It needs to have adjustable settings for different skin tones. It needs minimal setup. It needs to be water resistant and have a replaceable or rechargeable battery. My colleague will now continue the presentation.
Hello class, my name is Aguilar and I'm going to be talking about the intended users and uses of our UV alarm. The uses of our product will include beachgoers, those who spend a long period of time outside doing activities, people who enjoy tanning, health-conscious individuals, and individuals who are easily sunburned. All of these users spend a prolonged period of time outside and are exposed to UV light. As our skin cancer numbers around the world continue to increase, it is important that they protect themselves. As for the uses, it will detect overexposure to UV light and remind the user when to reapply sunscreen so that the damaging effects of the sun do not occur. When designing a new product, research on existing products within the current market is extremely crucial for any successful venture. Doing so allows us to pivot our minimum viable product into one that the customer will be completely satisfied with. During our research, we found a few products that were similar to our UV alarm. One product we encountered was the QSun UV Exposure Tracker. It is a wearable piece of technology that is able to keep track of the user's sun exposure to help prevent skin damage. It can be tailored to specific user needs. It can keep track of a variety of features other than sun exposure on the companion app as well. Our UV alarm will be able to surpass the quality of the QSun, as our product will be able to better satisfy the buyer. Many QSun buyers say that it fails to detect UV light in several environments, and that the companion app is actually extremely difficult to navigate. Reviews also mention that the alert system is easily missed due to poor vibration and low sound. Our UV alarm will be able to accurately measure UV exposure in several environments and have quality vibration and sound alerts and a mobile application with a user-friendly interface that all customers will feel comfortable with. The SunFriend Personal UV Monitor is another product that we came across in our research. The SunFriend monitors real-time UV conditions in a small coin-sized wearable waterproof package. It's a low-cost alternative comprised of silicone and fabric bands and is intended to be worn as a watch. The issue with this product is that once the battery dies, the device has reached the end of its usable life and cannot be reused. Our product will ensure that a rechargeable battery will be implemented so that a new device does not need to be repurchased. The UV alarm will also be comprised of better materials, better than silicone and fabric, so that it will be more durable while giving the customer more options to wear so it does not need to be worn as a watch. The last product we encountered in our research was the L'Oreal La Roche-Posay My Skin Track UV. My colleague will now continue with intellectual property.
Hello everybody, my name is Bryan Diaz Lunar from Team 8, and today I'll be presenting intellectual property. Intellectual property is an essential aspect of modern invention. It is very important for inventors, engineers, and designers to not infringe upon previously established patents, that is, to not incur any sort of legal liability. So for this project, we explored 3 patents related to our topic, and that is a wearable UV detection device. The first one being a UV detection devices and methods, the second one being ultraviolet ray measuring apparatus, an electronic wristwatch equipped with ultraviolet ray measuring functions, and 3, a portable apparatus and method for monitoring users' skin. For the first patent, UV detection devices and methods, the patent addresses 2 portable UV apparatus embodiments. It includes a UV detection device integrated with a skin type measuring device. It may include a controller that is in communication with the apparatus to provide the user with information on the current UV intensity in the environment. In this case, patent infringement is avoided as our project does not include any sort of separate skin detection device, nor a light sensor configured to activate the UV sensor as this patent posits. The UV alarm will require the user to select the desired alarm sensitivity level. It will also include the function to generate a beep or buzz to alert the user of overexposure to ultraviolet radiation, encouraging them to either apply sunscreen or perhaps seek shade. For the second patent, the patent is for an electronic wristwatch equipped with an ultraviolet ray measuring function. Infringement does not occur in this case either, as this device intends to measure and display UV intensity when aligned in a certain orientation. That is, this is a regular electronic watch that, when facing upwards, will inform the user of the current UV readings in their environment. It provides the user with no feedback on UV overexposure, nor does it allow any sort of customization. No patents are infringed. Now, my teammate Gabriel will present ethical considerations. Thank you.
How you guys doing? My name is Gabriel Sierra, and I'm going to talk to you guys about the ethical considerations regarding to our project. It is one of the most important things to consider when designing a new product due to the impact and feedback it will receive from its intended demographic. Even if a device is known to be manufactured, tested, and proven to have a good intentions towards its function, any undesired ethical issues might come and be detrimental towards the engineers, the institution, or the school that we're representing. So as engineers, we need to follow to 2 of the most used ethical theories. As a project, we're going to use ethical theories and the IEEE Code of Ethics. The IEEE Code of Ethics standard defines our duty as engineers to make sure that we create something while prioritizing health and safety for others. It's about 10 codes, and the one that we're going to use the most, adhere to the most, is number 3. It's the one that states that we have to hold paramount the safety, health, and welfare of the public to strive to comply with ethical designs and sustainable development. The reason why we're also using the ethical theories is because we consider it to be a more precise method. We're going to be considering utilitarianism, ethical egoism, Kantian ethics, and right ethics. Here we have a table with the options and descriptions. Option number 1, refuse the claim for faulty product. Option number 2, acknowledge the claims but choose to ignore it. And option number 3, accept the claims and fix their issues. In our testing, number 3 was the winner. Accept the claim and fix their issues. He had the highest score of the 4, which states to fix the faulty change, the claims, and whether it is by providing a new device or repairing the device itself. Based on the success, the best ethical option is to care for people's safety. Secondly, we have to also regard the social impact of a product, not in ethical considerations. In Sebastian, the Turning Tech Talk, What Your Design Says About You, he not only talks about how products provide a solution to a specific problem, but he also mentions how they present visions of the good life, how a product can be created for a better life, not for more profit. Our vision is that our product provides a solution to solve skin cancer and also presents visions of a life without burn or skin cancer. Our vision of the good life consists of lifestyle products, protects the people, healthier lives. We want it to be a time that people don't go to the dermatologist due to melanoma. They are rare occurrences, and where also mothers do not have to worry about their child's skin bleaching on the beach. Thank you. I'm going to give you guys Pablo, my colleague Pablo, to continue the presentation.
Hello, my name is Pablo Calderin, and I'll be discussing final concept. The intent behind the UV alarm is to simplify and improve the user's life by removing the worry of constantly being overexposed to UV radiation. The device will alert the user in multiple ways that it's time to apply more sunscreen or seek shade to reduce skin damage and sunburn. The goal is to cause a reduction in skin cancer cases and improve quality of life. In order to accomplish this goal, the device must be able to detect both UVA and UVB, have multiple wearable options, and a skin sensitivity setting. It is important that the device is cheap and accessible to everybody, as UV radiation is something we all deal with on a daily basis. Here we'll cover the concept selection. We decided the device will consist of a rechargeable battery for ease of use, will be made of a lightweight, flexible, durable material, as well as being water resistant, allowing the device to perform in any condition regardless of the user's choice. It must be able to sense UVA and UVB, like I said before, to provide the user with the most accurate reading possible, as well as a skin sensitivity setting to cater to each individual skin type. In addition, the device will have the option to switch between alarm types, such as the audible or physical vibration style for users' preference. Now I will discuss a brief summary of what we covered in the presentation. The product description will include our project's purpose and key components. In marketability, we cover the reasons why it is beneficial to invest and manufacture a device. In problem statement and objectives, we went over the needs and constraints for the client and user. In intended users and uses, we discussed the desired market and how our device accommodates their needs. In background and intellectual property, we covered relevant products and patents that are important to be aware of so we do not infringe on previous established work. In ethical considerations, we talked about our project's main ethical dilemmas and our solution options. And finally, in final concepts, we discussed our project's design requirements. Thank you.